Hello, my name is Malte Menkhoff and I'm working as a solutions architect here at KubeOne. This demo is about to guide you through a quick deployment of KubeOne. But before we start, we have to do some preparation. I'm using a wrapper script during this demo, which is called demo sh, which is just summarizing with options the different steps how you are deploying a Kubernetes cluster with KubeOne. So what I'm doing in the preparation stage is mostly that I'm getting the demo code. So I'm cloning my GitHub project where the code and the initial configuration is located. As this demo is supposed to run on the public cloud, and I've chosen Google Cloud as one example provider, I need to check my provider if I have a project where I can deploy my instances to it, and as well to have a service account that I can leverage the Google API. Before we are going to start in installing our software of KubeOne, I need to prepare the environment. So we are using here a declarative platform. So we are using here Terraform to deploy the infrastructure. First of all, we are initializing the backend. We are creating a plan. So the plan consists of 10 actions, which needs to be done with Terraform. We are deploying the networks. We are deploying routes to it, a load balancer, and as well the needed instances on Google Cloud. And this is gonna need around 1 to 2 minutes that the infrastructure is spin up. Let me quickly go on my presentation to give you some more background information about KubeOne. We will start in describing what is KubeOne. So KubeOne is a tool for managing Kubernetes clusters. Kubernetes clusters to manage means in this scope of the tool to install and to provisioning Kubernetes and upgrades, repairs, and unprovisionings of the clusters. KubeOne itself is open source and is provider neutral. KubeOne works on all your cloud, on-premise, edge, and IoT environments, and it supports all upstream supported Kubernetes versions. Why have we built KubeOne? So what we have seen is that Kubernetes brought us a new way for managing our workloads. But managing Kubernetes clusters is still a hard task. What we want to apply lessons learned managing workloads to clusters, and we want to manage clusters in a declarative way and not by scripts. During our engagement with our customers and potential customers, we have been searching for a long time for a feature complete solution, which we have not found on the market. So we decided to build KubeOne. Before I'm going to talk about what's included from a feature perspective in KubeOne, let us quickly deploy our KubeOne software code. So everything is built around one binary, which is called KubeOne. And what KubeOne is doing, KubeOne is leveraging the configuration file and the declarative way of Terraform. So we are connecting with the help of our Terraform configuration to the already deployed cloud instances on GCP. We are configuring the nodes, we are hardening them, and we are installing and configuring our software and as well the Kubernetes pieces of it. As this takes again around 2 to 3 minutes, let me quickly give you an overview about the features of KubeOne. KubeOne, as I mentioned before, is open source and provider neutral. KubeOne is a tool which supports you in the full Kubernetes cluster lifecycle. You can use KubeOne to install, to upgrade, repair, and unprovision Kubernetes clusters. It supports various nodes operating systems, so Ubuntu, as I'm using in my example here on the right side, but you can use it as well for deploying nodes with CentOS, RHEL, or CoreOS and Flatcar. KubeOne supports all upstream supported Kubernetes versions, and it is giving you a declarative cluster declaration, which brings you reproducibility in the deployment of Kubernetes. KubeOne as well helps you to automate the worker provisioning, and it is compatible with KubeADM by actually using it. KubeOne can optionally read Ansible, Terraform states and continues, and it has included the following batteries: the metrics server, OpenID Connect, pod security policy, dynamic audit backend, custom add-ons, and with the latest release of KubeOne, which has been announced just a few days ago, the cluster autoscaler function. We are very proud of it, that the cluster autoscaler function can be used as well on your on-premise environment, which we think is currently unique on the market. KubeOne as well supports an SSA jump pulse, and it supports to run in environments with a connection of a proxy. The installation is nearly done. So we see already that the control plane has initialized successfully. The last step, which is currently pending, is the machine controller. So we have installed the machine controller, and now the machine controller is come up. What we have deployed so far, and let me quickly show you it. Give me 1 second. Show you it just with my wrapper script. So KubeOne status gives you a short overview. So we have deployed a control plane. Don't be confused about the version. I have explicitly used an older version that we can show you as well how easy it is to upgrade a Kubernetes cluster. So our control plane has an API server which is healthy, and etcd is as well successfully deployed. We are using the mechanism of the machine controller, and the machine controller, what you can see here as well with the help of the cluster API, has deployed a machine deployment. In this machine deployment, there's a machine set, and this machine set has as well a cluster which is representing the controller node, the worker node. Don't be confused that you see here from a node perspective just one node. The second node, so the worker instance, will come up quickly. As no one would like to run Kubernetes with a single control plane, let us quickly enable HA. Enable HA means we are scaling out the control plane from 1 node to 3 nodes. Again, we are leveraging Terraform, so we are changing our Terraform's variables file and change just the control plane from 1 to 3. While Terraform is now doing all the action in the background in creating the 2 instances, and afterwards KubeOne, which is responsible for installing the software, let us have a look in the meantime on the supported providers. KubeOne is supposed to work on any provider and infrastructure, including as well on-premise and bare metal. Officially supported providers enjoy even additional features, such as support for managing worker nodes using Kubernetes Machine Controller, what you can see here. Automatically deployed cloud provider specific features like an external CCM, and the integration with infrastructure tooling such as Terraform, how I'm using it here in my demo. Officially supported public and private cloud providers are actually AWS, Azure, GCE, what you can see on the right side, DigitalOcean, Hetzner. For private cloud, you can use Packet, OpenStack, and VMware vSphere. More will follow, and if you are checking our GitHub repository, you can see as well actually that we have recently added 2 new public cloud providers. How to get KubeOne and how to start. So there are multiple ways to quickly get KubeOne. You can either use just an installation script, just curl it or download it and execute it. You can get it via get.kubeone.io. If you are preferring to use Go, you can just using Go in Go Get. You will find here as well the link to our GitHub repository. If you would like to download it directly, this is as well possible. And for our friends which are using Arch Linux, you can just get it from an Arch Linux repository, so pacman minus capital S KubeOne. The recommended version is on GitHub, available in version 1.1. Docs for this release can be found as well on our documentation website, so docs.kubernetes.com/KubeOne. It is explicitly described how you can get KubeOne. So everything what I'm mentioning in my slides is as well in our documentation. There's a quick start guide, the prerequisites to see what's needed. So configuring the credential on your public or private cloud providers, how you are able to deploy the infrastructure, provisioning, managing the worker nodes, upgrading Kubernetes, the maintenance, and its last step as well, the unprovisioning. We just need to wait some more seconds until everything is deployed. So let us have a quickly look on GCP Console. So what you can see here is we have not just one control plane, we have 3 control planes. It is actually not implemented in the load balancer. As you can see on the right side, we are still configuring the environment, so that will take a while. And the worker node is as well already here. So while the last few steps for the enabling of HA are running on the background, I can already start to give you a short comparison. So Kubernetes itself, besides training and professional services, has 2 software suites which you can use. We have on the one side KubeOne, which I'm showing here in my demo, and we have as well a second tool which is called Kubernetes. The main difference is for sure the scope, as KubeOne is designed to deploy a single cluster and manage as well a single cluster. Kubernetes is designed to support and to operate up to 100s of clusters. We have really done some testing, so it's even going into thousands if you would like to have so many Kubernetes clusters. The control plane type is differently, so KubeOne is leveraging a machine-based control plane, where Kubernetes is already using a containerized control plane. So the Kubernetes control planes are installed as Kubernetes workload on KubeOne. From a self-healing perspective, we have automated mostly everything which is needed to automatically do and provide self-healing for a control plane. As there are some things to do as managing the infrastructure, there are some certain tasks which needs to be done manually. If we are looking on Kubernetes, the self-healing functionality is fully automated and can be used. KubeOne has as a user interface the command line, quite handy and easy to integrate into CI/CD systems. Kubernetes itself has an UI for graphical interactions and mostly for demos and for quickly check what's happening, but as well a REST API which can be as well integrated into your landscape. Additional features of Kubernetes, which are currently not implemented in KubeOne, is a graphical user interface for the user management. So we are deploying as well a DEX instance, and with the help of the DEX instance, you can leverage your authentication of choice, which you are having in your company. You can do automatic backup with Velero. We have a monitoring stack included in the Kubernetes platform with Prometheus, Grafana, and Loki, and an easy way to leverage service accounts. What you can see on the right side now is KubeOne is deployed, and KubeOne as well has a control plane in an HA mode. So let us have a look with KubeOne status. You see already that we have now 3 control plane instances. They are up since a few minutes. Master with the status ready. The last step in my demo would be to show you how easy it is to scale out as well the worker nodes. So my wrapper script is just leveraging one command, and the command is kubectl, which is scaling the machine deployment of the K1 pool AZA from current 1 replica, so 1 worker node, to 3 replicas. Even when the command is running quite quickly and is coming back, you will see that this will take a while. The reason for it is just that the infrastructure needs to deploy a new instance, install the software, and integrating it into the cluster. So as mentioned before, our node, which is already running, is here ending up with 5 BG BQ, and we are deploying now in the background 2 new instances. And if we are checking again the GCP platform and reloading the VM instances overview, there should be already 2 machines up and running. So we are installing the software, configuring it, and afterwards it will be popping up as well as nodes to be used here in our overview. Takes some while. In the meantime, we can have a look as well on our documentation. So as we are limited in time in our demo, let us have a quick review on the upgrading procedure. So we are describing here the prerequisites, what needs to be done. It is quite easy. We need to have Docker, kubelet, kubeadm installed. All nodes needs to be healthy, and the Kubernetes version queue policy is satisfied. Upgrading the cluster is quite an easy step. First of all, we need to have a look on the KubeOne YAML configuration file and the Terraform JSON file. After we have changed to the latest version, we are just using KubeOne apply. The apply command is analyzing the given instances. We are looking what needs to be done. So in this current example here, we are upgrading from 1.18.5 to 1.18.6. After you have confirmed what you would like to do, the system is running in the background. Let us pause a while and have a look if we have already 3 worker nodes deployed. Control plane is still up and running. And what you can see here is that the second worker node is already deployed and ready for workloads. The third one is still not ready, but will come in a few seconds. Here we go, it is ready. The last point in my demo, as we are using KubeOne for the complete life cycle of a cluster, is as well to undeploy. This is in 2 steps. So the first step is a reset, and reset means we are deinstalling our software on the several nodes. And the last step would be to leverage as well Terraform again to undeploy the environment. So that would mean as well that we are deleting the machines on GCP, deleting the roots and all the other stuff. This was a short demo of KubeOne. If you would like to get more info about KubeOne, please feel free to reach to us. Many thanks and goodbye.